The science is dense, and politics get in the way. A million of people around the world talk about the climate crisis and how to slow it down. So, what exactly are we doing wrong, and how do we fix it?
Irrigation is the process of artificial supplying water to soil for raising crops. It is usually used in areas where rainfall is irregular or dry times and drought is expected. So how irrigation and crop fertilization can contribute to climate change? Irrigated agriculture consumes about 70% of the global freshwater extraction for food production. Almost 50% of the applied nitrogen that is widely used in the synthetic fertilizer is lost to the environment. The high irrigation water demand and fertilizer application in intensive agriculture cause a serious challenges for groundwater resources and their related ecosystems. For countries with arid or semi-arid climate, they will heavily rely on irrigation. Unfortunately, irrigation combined with the fertilizer have contributed to nitrogen pollution to the environment.
There are several ways to irrigation system that can be applied in the food production industry. However, they emphasize only two techniques, which are flood irrigation and drip irrigation. What is flood irrigation? A system where water is supplied to a field through pipes and ditch and allowed to cover the surface of land in continuous shape. The water standing just long enough in the field for soil to absorb the water applied to refill the root zone. Drip irrigation, a system in which water is supplied directly to plant roots using small diameter plastic pipe with a pressure and flow rate to meet the crop water requirement. Does the transformation from flood drip irrigation help to reduce the climate change? First, transformation from flood to drip irrigation reduces irrigation water use and groundwater discharge and nitrogen leaching.
There are several physics concepts that are applied in irrigation system, include fluid dynamics, pressure, thermodynamics, and heat transfer.
The main physics concept that apply on drip irrigation is fluid dynamics. From the equation of continuity states that area inversely proportional to the velocity, so small cross-sectional area will result high velocity, and we can relate this with Bernoulli principle, which velocity inversely proportional to the pressure, so high velocity will decrease pressure. So from this concept, the main tubes of the irrigation drip system should be bigger than lateral tube, which can help the flow of water and fertilizer move more effective. Apart from that, pressure is also important because it can ensure water move throughout the group. Farmers should put the tanks higher than land as it can increase the pressure.
The principles of thermodynamics are used to understand and optimize the energy efficiency of irrigation systems. This includes understanding how to minimize energy losses from friction, leakage, and evaporation. The principles of heat transfer are used to understand how heat affects irrigation system. This includes understanding how to design and operate the irrigation system to minimize heat losses and to minimize the effect of temperature on the water quality.
We can conclude that the drip irrigation system is the most efficient irrigation method, as it has the greater water use efficiency compared to sprinkler systems and flood or furrow system. By applying these concepts, engineers and scientists can design and operate irrigation systems that are more efficient, sustainable, and able to adapt to changing weather and climate conditions.